So for solving by elimination, what I'm going to do is in your book, so you can rewrite this, you don't have to rewrite this. There are steps for solving elimination or equations by elimination. I'm going to write those out on this set of notes here. Oops. And then I am going to go through some of the samples so that we can follow the steps side by side. Does that make sense? Mm-hmm. Okay. So when we're solving by elimination, what we're really trying to do is get rid of one of those variables. So just like in our previous two questions, we had an x and a y variable, and we had an x and a y in yesterday's for substitution, and we substituted something in for one of those so that we only had one variable. Today, we're going to get rid of one of those variables through subtraction, okay? And so our steps for elimination are as follows. So 1, make sure both equations are in standard form. Make sure both. EQN is my short form for equations. Both equations are in standard form. Does anyone remember what standard form is? Okay, I think you're on the right track. Yeah. Are you looking it up? Mm-hmm. Maybe. Okay, I'll give you a second. As you're looking it up, I'm going to write out the second step. I can find it. Okay, so standard form, I'll read the second step out to you guys in a second. Standard form here is our AX plus BY plus C equals 0. So it's when everything in our linear equation is equal to 0, not y. So if I can get this by rearranging. So if I have y equals mx plus b, all I'm doing is subtracting y from both sides, and I have 0 equals mx minus y plus b. This is the same as standard form, okay? A, B, and C are just numbers. We just don't know what those numbers are when we write out a general equation form like this. X and Y are still X and Y. Yeah. Like you don't get the standard form? So standard form is just a way of writing out an equation. So it is easy to understand. Yeah, so it's easier to understand or do things with. In the case of an equation like this one we're going to use, so I might as well show you what it is. Yeah, I use numbers. 2x plus y equals 7. Okay, this is not in standard form or slope-intercept form. Okay, those are two ways of writing out equations that help us get information out of them. Slope-intercept form would be if I minus the 2x from both sides, and I had y equals negative 2x plus 7. That's slope-intercept form. It gives us our slope of our line and our y-intercept. Standard form, I'm going to erase this because this is just a little side note here. Standard form gets everything equal to 0. So all I have to do to get this in standard form is minus 7 from both sides. So then I have 2x plus y equals 7, or minus 7 equals 0. Okay? This is standard form. The key for something being in standard form is having that equals to 0 written out somewhere. Okay? So that's step 1. So this is one of the equations I'm going to use. The other equation I'm going to use is, I'm going to write it out in purple here, 5x minus y equals 14. I'm going to minus 14 from both sides. And then I'm left with 5x minus y minus 14 equals 0. This is my equation 1. And this is my equation number 2. Okay, that's step 1 when we solve by elimination. Get them into standard form. Step 2 when we solve through elimination says, when I've already written it out here, multiply one or both equations by a number so that when you add or subtract the equations, one of the variables disappears. This step is not always mandatory. Okay, you don't always need to have it in. What we're going to do when we solve for this step is we are going to take our first equation, 2x, I'm going to put this in the right colors here, 2x plus y minus 7 equals 0. And we're going to have our other one, write it right below. So 5x minus y minus 14 equals 0. So this is equation 2. This is equation 1. What I'm going to check for when I look at these two equations is that if I add or subtract them from each other, that one of those variables will disappear. So let's check addition first. Because addition is always a little bit easier than subtraction. If I add 2x plus 5x, am I getting rid of my x variable? 2x plus 5x, does that equal 0? No. So that one I'm not getting rid of through addition. Y plus negative y, does that equal 0? Y plus negative y, does that equal 0? Yes. So if I add these two equations together, I can cancel out my y variables. Then I'll be left with 7x, because I'm adding 2x plus 5x together. And I'm adding negative 7 plus negative 14, which gets me negative 21. And that's going to be equal to 0. Okay? Solving for elimination, the goal is to get rid of one of your variables so that you can then solve for the remaining variable. So in this case, now I can add 21 to both sides. So then I have 7x equals 21. And then I can divide both sides by 7. And I get x equals 3. So the first point in my solution is 3, and I still need to find my y. Okay, but somewhere on my x-axis, or somewhere in my 3 on my x, there's going to be a y point where my two lines cross. Now I can take this 3 and I can do the same thing that I did when we solved for substitution, and I can plug it back into my original equation, or one of them. It doesn't really matter which one. I'm going to choose to plug it into this first one here. The numbers are a little bit smaller, so it just might make it a little bit easier to solve for. So if I plug it back in and I go 2 times 3, because I'm replacing that x with this 3 that I've solved for. If I plug it back in, I have 2 times 3 plus y minus 7 equals 0. Six plus y minus 7 equals 0. If I add 7 to both sides, I'm left with 6 plus y equals 7. Minus 6. Y equals 1. So then I can plug my 1 in for my point. Is this making sense? Okay, this is an easy equation. I want to do a couple more here, or one more for you guys, just because they're not always quite so straightforward. Which example do I want to do? Okay. I forgot to keep writing out the steps for you. I know. I'm just going to rearrange this so it's available to you guys online here. But our third step that we did here, you can write it anywhere on your notes, is solve for the one variable that remains. And substitute for step 4. Substitute this answer back in, into either equation. And step 5, solve for remaining variable. Okay, let's do another example. Move that over so that I can write right below it here. Okay, so I'm going to give us these equations here. We're going to use, first one is 2x minus 3y equals 7. And my next one is 3x minus 5y equals 9. Okay, so step 1 is rewrite these in standard form. And so I am going to start with my first one here, number 1, minus 7 from both sides. And I am left with 2x minus 3y minus 7 equals 0. Okay, rearranging my second one, minus 9 from both sides. And I'm left with 3x minus 5y minus 9 equals 0. These are my equations in standard form. These are the equations I want to use now for elimination. So if I write these one on top of the other here, I'm going to have 2x minus 3y minus 7 equals 0. And then right below it, I'm going to have 3x minus 5y minus 9 equals 0. Now let's do our checks. So we've done step 1. Step 2 says multiply one or both of the equations by a number so that when you add or subtract the equations, one of the variables disappears. So let's check addition first. Okay, if I add 3x to 2x, am I going to get 0? No. If I add negative 3y plus negative 5y, am I going to get 0? No. Okay, addition doesn't work. Let's try subtraction. 2x minus 3x, does that equal 0? No. Negative 3y minus negative 5y, does that equal 0? No. Shoot, what am I going to do? Now, if you are given the option, at this point, you might want to try substitution or graphing. However, if you're not given the option on a test or a quiz, or just because you don't like the other two methods, maybe, what we're going to do is this step right here. It says multiply one or both equations by a number. So I need to look at these equations, and is there something I can multiply my first equation by, and something I can multiply my second equation by, so that I get some sort of common term? Yeah, so I can look here, and I can go, okay, 2 and 3, those have a common, lowest common multiple of 6. So if I multiply my first equation by 3 and my second equation by 2, what I'm going to get are new equations down here. So I'm going to get 6x, because 2x times 3 is 6x. I'm going to get minus 9y minus 21. Okay, so all I've done here is multiplied each term by my 3x. Now I'm going to do that for my second equation here. And so I'm going to get 2x and 3x, or sorry, 2 times 3x, that's 6x, minus 2 times negative 5y, which is negative 10y. And then I'm going to get 2 times negative 9, which is negative 18. And both of these are equal to 0. Does that make sense so far? We're good? Yes? Okay. Now, if I were to look at these 6x and 6x, I know addition's not going to cancel them out, but I know subtraction can. So 6x minus 6x is 0. So I'm going to put a 0 there. And then I am left with negative 9 minus negative 10y, which is what? Negative 9 minus negative 10.
Negative 10.
If I have negative 9 minus negative 10. Two negatives. Yeah.
It's just y.
Yeah. Okay. And then negative 21 minus negative 18. So two negatives make a positive. Negative 3. Yeah. Okay. So I can add 3 to both sides. And then I'm left with y equals 3. So then in my point here, I just need to substitute back in to solve for my x variable. Okay, so do we want to do equation 1 or equation 2? You pick, let me know. 1? Okay, so in equation 1, I have 2x minus 3y equals 7. It doesn't really matter where we put it, if we use the original or the standard form. I'm going to replace my y with 3. So I've got 2x minus 3 times 3 equals 7. So 2x minus 9 equals 7. Add 9 to both sides. 2x equals what? 7 plus 9. 16. Divide both sides by 2. Yes. I'm just going to write it over here so it doesn't get cut off later on. X equals 8. So then I can plug that back in for my answer here. Does that make sense? Okay, so we've done 2 elimination problems. One where we have to find the lowest common multiple. So we got to think back to whatever unit we've done before. And another where we did not have to find lowest common multiple. No questions so far?